problem. A company manufactures two products, A and B. It takes 30 minutes to process 1 unit of product A and 15 minutes for 1 unit product of B. The maximum machine time available is 35 hours per week. So 1 unit of product A requires 2 kg of raw material, while product B requires 3 kg of raw material per unit. So the available raw material is limited to 180 kg per week. That means this is the constraints. So the product A and B have unlimited market potential and sell for 200 rupees and 500 rupees per unit respectively. And the manufacturing cost of the products are also given, which is in quadratic form, that is 2x square and 3y square respectively. Find how much of each product should be produced per week, where x and y are respectively the quantities of A and B to be produced. So for the solution, that means formulation of the problem, first we make, that means objective function and corresponding subjective constraints, and here we use two decision variables, that means x and y. Both decision variables are positive, because when any company produce type product of A and type product of B, that will be not be a negative. So that means the decision variable always be a positive quantity. So we write the solution. Solution of the problem. That means let x and y, we write as let x and y be the quantities, quantities of products which is products are A and B, products A and B respectively. So this is given that here A and B, two types of products. So we assume that x and y be the quantity of products A and B respectively. So which are manufactured per week. So here given as production is per week. So we write as which are manufactured per week. And the total selling price, here we write the total selling price of product A and B of, we write as product A and B are 200 rupees and 500 rupees. 200 rupees and 500 rupees per unit respectively. So when the total revenue, that means x and y are the quantity of products, and per product unit cost is 200 rupees for type A product and 500 rupees type B products. So we can say that the total revenue per week, what is total revenue per week, which equal to 200 into x or plus 500 into y, because x and y are the quantities. So that means 10 quantity sold of X types and 20 for Y. So that means total revenue generated as 200 into 10 plus 500 into 20. If X and Y are considered as quantities, so this is the total revenue per week. That means we go for the question and read this line. If the manufacturing cost, so this is the revenue which is generated by selling. So this is the revenue which is generated when product is selling. That means 200 rupees for product A cost and 500 for product B. But we move here, that means if the manufacturing cost of product A and B are 2x square and 3y square, that means this is the manufacturing cost. So we write or we mention here the manufacturing cost of product A and B, per week. This is also cost A and B are 2x square and 3y square, 2x square and 3y square respectively. So when total revenue which is generated as 200x plus 500y and the cost, manufacturing cost are 2x square and 3y square. So what is the profit? How to write the profit? That means we make the objective function. So when we subtract manufacturing cost from the revenue, gives the profit. So we can write the profit per week, which equal to revenue cost, that means revenue generated, revenue per week minus manufacturing cost, So this equal to 200x minus 500y plus 500y minus 2x square plus 3y square. So this is the profit per week. So we can write this function as 200x plus 500y minus 2x square minus 3y square. So profit per week. Now this is our objective function. Now we make the constraints. So for making constraints, so we again read the question. That means if it takes 30 minutes to process 1 unit of product A, 30 minutes to process 1 unit of product A. So type A product, quantity of product A, that means X, we consider as X, and type B of product we consider as Y. So 30 minutes of product A and 15 minutes of product B. So we write as the machine takes 30 minutes of product A and 15 minutes for product B, and the maximum machine time available is 35 hours per week. 35 hours per week. So 35 hours per week. This is talking here in the minutes. So 30 minutes process time of product A and 15 minutes of time process of time of product B. And he have a total available time in hours. So we make all the constraints in the minutes form. So that means we write as the maximum time available 35 hours. So then the constraints we make as the first product take 30 minutes, that means X type products, X quantity produced takes 30 minutes, X and plus second take 15 minutes, that means Y total time is available 35 hours. So we make hours into the minutes by multiplying 60. So this convert into minutes. So total we can write as 30x plus 15y less than equal to we multiply this. So 0 0 6 3 ja 18 18 or 3 21. So here we can divide by 15 again. So we write as 2x plus y less than equal to 15 1 ja 15 and 15 4 ja 60. So 140. So this is the first constraint. So on the basis of question, that means 30 minutes time process 1 unit of product of type A, that means, and 15 minutes for type B. Total availability is 35 hours. So we can make hours into the week. And next constraints, if one product, then we read this one product, that means 1 unit product of A require 2 kg of raw material, while product B require 3 kg of raw material. So the available raw material is 180. So this is availability. We can make a second constraints. So the constraints make on availability, makes on availability. So here 2x and second having 3y, or total availability is 180. Total availability is 180. So this is 180 kg per week, the available raw material. So this is the second constraint, and we have x and y. X and y are non-negative. Non-negative. So we can write as the problem can be expressed as profit. When in case of profit, the problem is maximization, objective function, maximization, two variable f of xy, which equal to 200x plus 500y minus 2x square minus 3y square, and respective subject to constraints. Constraints are, first is 2x plus y, 2x plus y less than equal to 140, and the second constraints are 2x plus 3y, which is less than equal to 180, and we write as xy greater than equal to 0. So this is the formulation of the problem. Here we Define, that means the objective function or subjective constants are in non-linear form. So we see that this is non-linear form. So objective function in non-linear form. So this is the formulation of non-linear programming problem. Formulation of non-linear programming problem. So question can be asked in the form, that means paragraph is given. So you have to formulate the problem. What is the first constraints on the availability of raw material, second constraints, and what is the objective function of this. So you can construct the problem. Devanshi, Manshi, you noted? Okay. So we have, this is the paragraph, that means problem, and on the basis of that we use two variables because already defined here, x and y are respectively quantities of A and B to be produced. So we write the same, and first we find out the what is the total revenue generated, and the manufacturing cost, we subtract manufacturing cost from the revenue per week. So this is the profit where means objective function, and we make the constraints. Okay. So we take next problem. Try to solve this problem and write in chat box the constraints and etc. Just take. This is the problem. So we formulate this problem. Formulate the given problem. So we make the formulation. That means first we understand the language. So the manufacturing unit produce two products. Radios and TV sets. So the production cost of each product depend upon the number of units being produced. If X1 and X2 are the number of radios and TV set produced. So here two variables are given, X1 and X2. So then the production cost. Production cost is also given 200x1 plus 0.2x1 square and 300x2 plus 0.2x2 square respectively. So there is the restriction on the production capacity of the radio and TV sets are 180 units respectively. So this is the restriction are given. And similarly, there are the restriction on manpower available. So that is this first one is the first constraint, and the second is the second constraint, which is based upon the manpower availability. So manpower available, a total 520 man days are available. So the production of one price of radio required 2 man days, and one TV set required 3 man days per day. So the sale price is dependent upon the quantity to be produced and sale. Relationship are given as this table. That means product radio sets quantity demand 2000 minus 5p, p with the unit price, and TV sets are 4000 minus 10q, and q with the price of the TV sets, unit price of TV sets. The problem is to determine the number of radio and TV sets which are produced to maximize the profit. So first we formulate the problem, then we solve this problem. For solution, we discuss later because we have two methods. First is Lagrange multiplier, second is Tucker conditions. So first here we formulate the problem. Now, so for formulation of the problem, so given as x1 and x2 are the number of radio set and TV set produced. So we write as, let x1 and x2 are the quantities of radio sets and TV sets, radio sets and TV sets which are produced by firm. Any firm produce two types of products, that means x1 and x2. Quantity demanded. So the quantity demanded, that means product, the first is radio sets. Radio set we consider as x1. So the x1 equal to, we write as 2000 minus 5p1, 5p. And for TV sets, so this is x2 equal to 4000 minus 10q. P and Q be the unit price. So you can write the value of P and Q. So what is the value of P and Q here? So you see the value of production. That means this is the production cost. Production cost are this, that means P unit price per item, that means then the production cost is this. So we write as P equal to we write the production cost. So 200, and we make the constraints from P right here. First we write P from here. So what is the value of P here? So we can write P as 5P equal to, first we write for this, 5P equal to 2000 minus x1. So we write the value of P equal to 400 minus 1 upon 5 x1, 1 upon 5 x1. So this P equal to 400 minus 0.5 into x1. So this is the value of P according to the this. So we use this, then we discuss. And for the value of Q, so for value of Q we use this equation. So the value of Q you write as x2, that means 10Q equal to 4000 minus x2. So you write as 4000 minus x2. So Q equal to 400 minus 1 upon 10 into x2. So this equal to 400 minus 0.1 into x2, 0.1 into x2. So this is 0.5 and 0.1. So this is the value of Q. X1, X2, we two quantity of radio sets and TV sets which are produced by the firm, given as X1 equal to this quantity demanded, and this is these are the unit prices. So we calculate the prices here, that is P and Q in terms of X1 and X2. And if we write, if the total production cost, if the total, we read the question, total production cost of which items? X1 items. That means X1 unit of radio sets, X1 unit of radio sets, and X2 unit of X1 unit of radio sets, and X2 unit of TV sets, So which is denoted as C1, that means we write the cost C1 and C2 respectively. So on the basis of this, that means this is the production cost. The production cost are 200 x1 plus 0.x2 into x1 square, and so this is the production cost. We write in the form of C1 C2. So C1 equal to 200 x1 plus 0.2 into x1 square, and C2 equal to 300, which is 300 x2 plus 0.2 x2 square, 300 x2 plus 0.2 x2 square. So this is the production cost. So how to calculate the revenue in as previous question? So the total revenue, that means revenue of radio. We find out the total revenue of the firm. So that means revenue of radios plus revenue of TV sets, revenue of radios and revenue of TV sets, radio sets or TV sets. So this revenue we can denote it as R, revenue R. So the revenue generated of TV sets revenue generated, the unit price is P. So P into X1, we write as P into X1 or plus Q into X2. So Q and P and Q are the unit prices of product X and Y. So P of X1 and Q of X2. So P of X1, so the value of P, price P, we find here. So the price P is 400 minus 0.5 X1. 400 minus 0.5 X1 into X1 or plus Q. Q equal to 400 minus 0.1 X2 into X2. So this is the revenue. So we write this as 400 X1 minus 0.5 X1 square plus 400 X2 minus 0.1 X2 square. So this is the revenue. So revenue generated per item, and the total profit. So what is the total profit? So total profit. How to calculate the total profit? Total profit, that means this is the production cost. So we subtract this cost from the revenue. So total profit we write as R minus subtract the production cost. Subtract the production cost. So we write as profit P equal to R equal to 400 X1 minus 0.5 X1 square plus 400 X2 minus 0.1 X2 square, and C1 C2. What is the value of C1? C1 is 200 X1 plus 0.2 X1 square. So minus 200 X1 plus 0.2 X1 square. 0.2 X1 square. This is C1, and 300 X2 plus 0.2 X2 square. We write as plus 300 X2 plus 0.2 X2 square. So this is the production cost of C1 and C2. That means radio sets and TV sets. So now we find out the profit. So the profit is profit P 400 X1 and here 200 X1. So this is 200 into X1 and 400 X2, 300 X2. So that means my plus 100 X2, 0.5 X1 square, and here 0.2 minus 0.2 X1 square. So this is 0.3 X1 square, 0.5 X1 square, and 0.4 and 0.1 minus 0.2, 0.3 X2 square, 0.3 X2 square. So this is 200 X1, this is X1, C1, 0.5 X1 square. So minus 0.5 X1, or here is minus 0.2, 0.7. So this is minus 0.7 X1 square, and here this is minus 0.1 and minus 0.2 X2 square. So minus 0.3 X2 square. So this is. So we write the P as variable taken in this form, and 100 X2 minus 0.3 X2 square. So this is the objective function. That means profit is the objective function. Now for subject to constraints, we make the constraints. So you read this. So our work is done till here. That means we have done this. Now there is a restriction on the production capacity. There is a restriction on the production capacity of radio sets and TV sets. Radio sets and TV sets. So the radio set we consider as X1 quantity of radio sets and X2 set as a TV quantity, TV sets, X2 quantity. So the production TV radio sets are 100 and TV sets are 80. So these are two constraints. That means the constraints as per production that means we restricted that radio sets are 100, so x1 is less than equal to 100 we can produce, and x2 TV sets we can produce as 80. So this is the first two restrictions, that means 100 for radio set and 80 for TV sets. Similarly, now we move this. There is a restriction on the manpower available. Restriction on manpower available. So total 520 days are available. So we make the another constraints on the basis of that. So man days are available is also limited. That means these are the 520. So production, one piece of production required 2 man days, and 1 unit of a TV set require 3 man days. So we can construct the another constraints. So this constraints we write as this constraints based on manpower. So two man days. Yeah, radio set, one piece of radio set required 2 man days. That means 2 of x1. 2 of x1. 2 of x1 and plus 3 3 man days are required for TV sets. 3 man days are required for TV sets. So this is 2x1 plus 3x2, and we have to restrict it. Total man days are available 520. Total man days are available 520. So this is the third constraints. So we make a model. So for making the model, that means we require all the constraints are non-negative because we are producing radio sets and TV sets. So this cannot be negative. So that means all the restrictions are positive, greater than equal to 0. So we can write as, so then optimize function, the objective function, which are in the form of profit. So we write in maximize of z, which is, yeah, this is the profit. So 200x1 we write as 200x1 minus 0.7 x1 square. So 200x1 minus 0.7 x1 square plus 100x2 plus 100x2 minus 0.3 x2 square minus 0.3 x2 square. So maximize that, and the subject to constraints are x1 less than equal to 100, x2 less than equal to 80, and for manpower 2x1 plus 3x2 man days are available, which is less than equal to 520, and x1 x2 are greater than equal to 0. So this is also the Non-linear programming problem. Non-linear programming problem. So for two variable, here this is the formulation. Then for solution, same as two variable case, we use graphical method, and two or more than two, Lagrange multiplier method. This helps the restrictions, that means equality constraints. Solve only equality constraints. And Tucker condition. Inequality constraints. So we solve the problems by using these methods.